Hi guys, here's another video about the CSS Pure Mathematics Exam from 2023. This is section C, and we are going to solve question 7, item B. So the question asks us to evaluate this contour integral of the function 1 over z to the 5 plus z cubed, where c is the upper arc of the unit circle oriented from 1 to minus 1. So let us begin. So first, we sketch the curve over which we want to integrate. So here's the curve. We have this arc of the unit circle. And as I mentioned, it is oriented from going from 1 to minus 1. So it is oriented counterclockwise. Okay. So now let's take a look at the function we want to integrate over C. So if we look at this function, it is here we have a 1 over z to the 5, which is a rational function, plus z to the z cubed, which is a polynomial. So here we have a rational function. And the only point in the complex plane for which this expression is not defined is 0. So this function is defined on C minus the origin. Okay, and in this domain, it is continuous. So therefore, it has a primitive. So since this curve doesn't pass through the origin, we have no problem. We will have no problem integrating, and we will be able to apply the fundamental theorem of calculus in the complex case. Okay, so let's do that. So first, here's the function we want to integrate. This function is continuous, and as I mentioned, it is defined on C minus the origin. And it is easy to see by integration that this big function, big F, is a primitive of F. Because here we have 1 over z to the 5, so it is easy to see that a primitive of 1 over z to the 5 is minus 1 over 4 times z to the 4, plus, and a primitive of z cubed is z to the 4 over 4. So this function is a primitive of f. Now, all we have to do is use the fundamental theorem of calculus in its complex version. So we need a parametrization of the curve over which we want to integrate. We could take any smooth parametrization of it. I chose one so the problem could be more concrete, but I could just say take one, and I didn't even need to specify it, but I chose to present one. So here we have gamma from 0 to pi, which takes t to e to the power I times t. And now we apply the complex version of the fundamental theorem of calculus. So the integral we want is that. So this is what I call f. So it's the integral of f over c. But the fundamental theorem of calculus for this complex version of it tells us that as long as we manage to find a primitive of f, all we need to do is find the difference of this big F in the points, in the starting and ending points of the curve. So the end point is gamma of pi, which is minus 1, and gamma of 0, which is 1. So we have f of minus 1 minus f of 1, and now we plug this expression in our f. We call that in the big F. We call that big F is this. So we get this, and this is 0. And we are done. Thank you very much. I hope you enjoyed the video. Please give me a thumbs up, subscribe to the channel, and soon I'll post more videos. Thank you very much again. Bye.